Okay, so this lesson is on using properties of exponents to evaluate and simplify expressions involving powers. And then we'll use some of those things to solve some problems. So just to quickly run through all of the properties of exponents, the first property that we're going to go over is called the property of powers. So it is when you are multiplying two terms, both with the same base number that have exponents. When you're multiplying those two together, your shortcut is really just to add those exponents. So for example, if I were to be doing this problem, I have 2 to the third power, which is really 2 times 2 times 2. And then I'm multiplying that by 2 to the fifth power, which is really 2 times itself 5 times. And therefore, I'm really multiplying 2 by itself 8 times. So my answer there would be 2 to the 8th power. Now, it's a lot quicker to get that answer by simply just adding up those exponents. For number 2, x to the 4th times x to the 10th, we would just then add those exponents to give us x to the 14th. And for number 3, we have y to the 3rd, a y, which is really like y to the 1st, and then y to the 8th. And when we add those exponents, we get y to the 12th. Okay, so moving on to the next property, which is power of a power. So this is when you have an exponent term, and then outside the parentheses, you have another power. So you're raising this entire exponent term to that power on the outside there. So what you're going to do in that case is you're going to multiply those two exponents. So for example, if I have 3 to the second, and then I'm raising that term to the third power, that means I really have 3 to the second times 3 to the second times 3 to the second. And of course, each of these 3 to the second powers is really a 3 times 3. So that in turn then gives us 3 raised or multiplied by itself 6 times, or 3 to the 6th. Now, if we had just multiplied those two exponents, the 2 and the 3, we would have been able to get 3 to the 6th, doing it that way as well. So for number 2, we're going to multiply the 5 and the 4, and that will give us x to the 20th power. And then when we do number 3, first we want to take care of this part here, this power of a power. So that's going to give us y to the 56th. And then we're using our original property there, product of powers, and we're just adding those two exponents. So y to the 59th. Okay, then our third multiplication property is power of a product. So this is when you have two things being multiplied inside those parentheses, and then you have the exponent on the outside. Each of those terms on the inside is going to be raised to that power. So whether it's a number, like here we have a 2, so that's going to be 2 to the 4th power, or here we have a variable term with the exponent x to the 3rd, that's also going to be raised to the 4th power, giving us x to the 12th. And then 2 to the 4th power, you could work that out, calculating it out, 2 times 2 times 2 times 2, and you get 16x to the 12th. For number 2, that 6 on the outside is going to be applied to each of those terms. So you get x to the 18th and y to the 30th. And then for number 3, we're going to have 3 squared times x to the 8th, because 4 times 2 is 8, times y to the 6th, because 3 times 2 is 6, times z squared. 3 squared then can be worked out a little bit further to get the 9, and then this would be our final answer. Okay, so moving down. So now the next property we're going to talk about is negative exponents. So in many problems that we do, we're not allowed to leave, let's say, a radical in the denominator or something like that. With exponents, the main rule is you're not allowed to leave negative exponents in your final simplified answer. So anytime you have a negative exponent, you need to make it positive. And the way to do that is to basically write it as a reciprocal. So any term that has a negative exponent, if you rewrite it on the opposite side of the fraction, then that exponent is no longer negative, it's positive. So if the number itself is actually a negative, that doesn't change, it's just the exponent. So when things are not in fraction form, I like to put them over 1 and kind of think about it more like a fraction. And since this 2 has a negative exponent, if I rewrite my 2 on the opposite side of the fraction bar, I can then make that exponent become positive. And if it is something that you can calculate out, then you would do so. So this would become 1/8. Now, if you take a look at number 2, it's the same type of situation, except this time the number with the negative exponent is on the bottom. So I'm going to move that 3 up to the top, and now my exponent is positive 2. That, of course, would just be over a 1 because there's nothing left in the denominator. So then when I go to calculate it out, I can just get 9, and I don't need a 1 on the bottom. Now, when you take a look at problem 3, we'll notice that we have 2 terms here with negative exponents. So in this particular case, be careful because the z has a positive exponent already, so it doesn't need to move anywhere else. It's going to stay exactly where it is. The x, however, has a -4, so that's going to move down to the bottom so that my 4 can become positive. And the y has a -3, so that's going to go up to the top so that 3 can become positive. And then that would be your final answer. Okay, then 0 as an exponent, something that you just kind of want to remember, anything raised to the 0 power is simply just equal to 1. So you can just remember that. It doesn't matter if it's a number like 3 raised to 0, that would be 1. A variable like x raised to 0, that would be 1. A whole bunch of terms all inside those parentheses raised to 0, that would all equal 1 as well. Okay, quotient of powers, similar to the product of powers that we went over in the beginning. When we're multiplying two numbers, we add the exponents. If we're dividing two numbers that have exponents, we would subtract them. So for example, here you have 3 to the 5th over 3 to the 3rd. So that would be 3 to the 5 minus 3, which of course is 2. And then this one can be worked out all the way to 9. If you take a look at number 2, you would have x to the 8 minus 2, which equals 6. So x to the 6th would be your answer. Now I want to go look at this a little bit more because notice in all of those problems we were taking the top and subtracting the bottom exponent from them. And it worked out nicely because the exponent on the top was larger than the one on the bottom. So for example, if you have x to the 8th, that really means you have 8 x's on the top and you have 2 on the bottom. So if I'm going to go cancel out 2 on the top with the 2 on the bottom, I have 6 left, and of course they're on the top, so it's not a big deal. Now, for example, sometimes you could end up with a problem where you have a smaller exponent on the top. So let's say you had x to the 3rd over x to the 7th. Well, if you went to subtract this, you would do 3 minus 7, which of course equals -4, and we're not allowed to have a negative, so then you'd have to move it to the bottom. Now, the way I like to kind of think about these problems so that I don't get a negative and then I don't have to flip the negative is that I always remember that however many x's there are, or numbers, or whatever it happens to be, the bigger number, wherever that is, in this case 7 is bigger than 3, your answer is going to end up there. So if you just subtract the numbers in order to always get a positive answer, so instead of doing 3 minus 7, if I just do 7 minus 3, I get 4. Well, 7 minus 3, I have 4, but they're going to be left on the bottom, so I know right away my answer will be 1 over x to the 4th. So instead of worrying about top minus bottom, and then if it's negative, flipping it, I just always subtract them to get a positive answer regardless. If the bigger number, if the bigger number is on the top, then my answer is going to go on the top. If my bigger number is on the bottom, like here at the 3 and the 7, then my answer is going to go on the bottom. And that's another way you can kind of look at it so you don't have to deal with the negative. Okay, so for number 3, I have these two x's. So right there is a good example. So I have 10 x's on the bottom and 4 on the top. So 10 minus 4 is 6, and my answer is going to go on the bottom because that's where I had more x's to begin with. When I look at my y's, though, 7 minus 2 is 5, but that answer is going to go on the top because my 7 is bigger than 2, and that was on the top. So now we're going to talk about power of a quotient, and this is when you have a fraction inside of your parentheses with an exponent on the outside. Just like we did before, anytime there's parentheses, that exponent is going to go to everything inside the parentheses. It doesn't matter if it's part of a fraction or just part of a product or anything, that exponent needs to be applied to every number and variable inside. So for number 1, this would become 2 to the second over 3 to the second, which of course can work out to 4/9. If we were doing number 2, the 4 is going to go to the x squared, making it x to the 8th. It will also go to the y on the bottom, making it y to the 4th. And then number 3, this 5 has to go to the 2. It also has to go to my x squared and my y cubed. So this would make it 2 to the 5th times x to the 10th on the top. Notice both times it became an exponent. Now, a lot of people get confused, and they might want to do 2 times 5 here. But remember, this 2 really has an exponent of a 1. So 5 times 1 is 5. So it's 2 to the 5th, x to the 10th, and then on the bottom, y to the 15th. And of course, 2 to the 5th can be worked out to 32. So that's what our final answer would look like there. Okay, so let's just do some practice with using these properties. Okay, so number 1, this is just the products here. We're just multiplying these terms together. So all we're going to do for this one is add those exponents. So 3 plus 8 plus 4, and we get 15, x to the 15th. All right, then, oh wait, I'm sorry. I didn't even realize that was a y there. So we have 2 x's. So x to the 11th, and then y to the 4th. Okay, the next one, we have the 2 m's. So that's going to subtract. This is really a 1, so I have m to the 4th on the top. And then when I take a look at my n values here, again, I have the bigger one on the top. So 12 minus 3 is going to give me n to the 9th. And I could put over a 1, but that's not really necessary. Okay, number 3, I'm going to cancel out my y and only my y because that's raised to the 0. But the 8x to the 4th are not raised to the 0, so those remain. Okay, number 4, this 4 is going to go to the 3 and the x to the 6th power, making it 3 to the 4th times x to the 24th. And then, of course, 3 to the 4th works out to 81. Okay, number 5, I have one term here that has a negative exponent. So just that one term needs to be moved. The a to the 3rd and the c to the 4th are going to remain on top. And the b to the negative 5 goes to the bottom so that the 5 can become a positive. Okay. All right, then over here I have x to the 5th times x to the 10th, which is going to give me x to the 15th. And then I have my 2 y's, and when I add those exponents, I get 17. So that would be my answer there. Okay, number 7. So here, the first thing I'm going to do is get rid of this negative exponent. So I'm just going to rewrite everything, but I'm going to move this x to the top so that that 3 can be positive. At this point now, x to the 7th times x to the 3rd is going to give me an x to the 10th because I'm adding the exponents. And 8 over 2 is just normal division, 8 divided by 2. So that's just 4. And then, of course, we don't need the 1 on the bottom. Since there's nothing left there, we can just write it as 4x to the 10th. Okay, so now number 8, each of these terms are going to have that 4 brought down to them. So then I'm going to multiply the 3 and the 4. So I have m to the 12th on the top, and 8 times 4 would give me 32. So n to the 32 on the bottom. All right, my next term here, the x cancels, and then that y will have to go down to the bottom. The z is fine where it is, so it's just going to stay on the top, and then I have y to the 3rd on the bottom. Okay, number 10, this becomes x to the 30th because I have to multiply. And now I'm going to add these because I have 30 x's and 4 x's, so altogether I have 34 of them. Okay, next one, this -2 has to be brought to each of my terms, and then those exponents are going to get multiplied. So 3 times -2 is -6. -2 times -2 is +4. And then on the bottom, 4 times -2 is -8. Now, of course, the two negative exponent terms have to be moved to the opposite side, but the h gets to stay where it is. So the j goes to the top, so the 8 becomes positive. The g goes to the bottom, so the 6 becomes positive. The h stays where it is. All right, and then going on to the last one. Now, don't get confused because you see this multiplication sign in the middle, because really everything that's smushed up next to each other is getting multiplied anyway, so it really doesn't change anything. So there's no parentheses, there's no negative exponents, so really I just want to combine like terms that I can. So 2 times 6, for instance, I'm going to multiply. X to the 3rd times x to the 5th, I'm going to multiply, and then I'm going to go from there. So 2 times 6 is 12. X to the 3rd times x to the 5th, I add my exponents and I get x to the 8th. And then y times y to the 3rd, I will add my exponents and get y to the 4th. On the bottom, same thing, 3 times 2 is 6. And I have x to the 2nd and y to the 4th. Now at this point, my y to the 4th are the same, so they're just going to cancel out because 4 minus 4 is 0. 12 divided by 6 is simply just 2, and x to the 8th over x squared. I would subtract my exponents and I would get x to the 6th. All right, so moving on, we're going to apply some of the simplifying to some of these geometry formulas. So we're going to write an expression for the area or volume. So we're not solving it, we're just simplifying the expression. So we're going to plug into the formulas that are provided. For this first problem, they're giving us the radius of this circle here, which is 4x, so that's going to get plugged in for the r. So a will equal pi times 4x is my radius, and that's going to be squared. So just using the properties we went over, this little 2 has to be applied to both the 4 and the x. Now, of course, I can work out my 4 and make it a 16. So my answer would be 16 pi x squared. Or if you actually multiply the 16 pi out, I believe you get 50.27. And then you'd still have that x squared. So either form of that answer would be fine. Okay, so let's take a look at the area of a triangle now. So the formula we're going to be using is down here. So area equals the radical 3 over 4 times the side squared, and that's what I'm putting in for my s there. So it's going to be x over 2 squared. Now remember that 2 has to apply to both the numerator and the denominator. So I'm going to have x squared on top and 2 squared on the bottom, which is 4. So now on the top, I have radical 3 times x squared, and on the bottom, I would have 16. All right, so now we're going to do volume of the right cylinder. The 2x that they're giving us here is going to be the radius, and then this x here is going to be your height. So the volume equals pi times 2x for my radius squared times another x. So first thing I want to do is get rid of my parentheses by using that property that we did earlier in the notes. So this is going to be 2 squared times x squared. Now, of course, 2 squared is 4, so I have 4 pi here. And x squared times x, I add my exponents and I get x cubed. So my volume here would be 4 pi x cubed, or if you did want to multiply out, 4 pi is equal to 12.57 x cubed. All right, so then the next one here, we have volume equals 4/3 times pi times my radius, which happens to be a fraction x over 3, and that's going to be cubed. So typically the first thing I like to do is get rid of those parentheses. So this is going to be x cubed over 3 cubed. So now on the top I have 4 pi x cubed, and on the bottom I have 3 to the 4th. Now the 3 to the 4th, you could actually work that out, right? So I have 4 pi x cubed over 81. Okay, so moving on. So now we're going to do some scientific notation. So scientific notation is a very short, convenient way to write very large and very small numbers. Now, the general form of scientific notation has to be that there's one number in the front, and then it's like times 10 to some power. However, the C value has to be a number between 1 and 10. So it can be a decimal like 1.8 or 5.7, but the number in front of the decimal can only be one digit. That would make it a number between 1 and 10. So once you get to 10, that's 2 digits. So it's not scientific notation. You have to move that decimal over again. And if you have a number smaller than 1, it's going to be like point, something, and then that would not be proper scientific notation either. To start with just the decimal, you have to have at least one number in front of it. So you have to make sure your answer is in scientific notation. Now, just to review, multiplying numbers in scientific notation. Okay, so this is not on here. I'm going to write it down. So let's say you had 2.4 times 10 to the 3rd, and then you had 5.3 times 10 to the 5th. So in scientific notation, to work with it, you would do 2.4 times 5.3, because those are like your like terms, and you're going to get 12.72. Then you're going to multiply your 2, 10 to the whatevers, right? So you have 10 to the 8th, because you're going to add your exponents. Now, the only catch is, like I just mentioned before, this is non-proper scientific notation because you have 2 digits in front of the decimal. It's 12. It's not a number between 1 and 10. So you'd have to move that decimal over to make it 1.272. Now, the way I kind of remember what to do with the second half is if I make this number smaller, which I did, I made a 12 into a 1.2, your exponent will have to make up for that by getting 1 bigger. So because I moved my decimal place once, I know I'm going to have to do a change of a 1 on that exponent, but because I made my number smaller, my exponent's then going to get larger or bigger. So it's going to be 10 to the 9th. So that would be my answer for that multiplication there. Okay, so let's take a look at the division. Or actually, here's another example I'm going to do too. So if you have 7.9 times 10 to the 4th, and then let's say that's squared. So just like we did with the properties earlier, this 2 would have to go to the 7.9. It would also have to go to the 10 to the 4th. So 7.9 to the 2nd power is 62.41. And then this will be 10 to the 8th, because 4 times 2 is 8. Now, again, you got to check because this is no longer in scientific notation because the decimal is in the wrong place. So I have to change my 62.41 to just 6.241. And since I made that number smaller by moving the decimal once, I'm going to make this bigger by adding 1. and that becomes 10 to the 9th. So that's kind of how you do some of these operations with the scientific notation using those properties we just went over. And division would be the same thing. So I'm just going to put a division one up too. So let's say you had 16.8 times 10 to the 5th divided by 8.4 times 10 to the 3rd, let's say. Well, 16.8 divided by 8.4 would just give you 2. And then here you would subtract those exponents and you would get 10 to the 2nd. Now this is already in scientific notation, so I don't have to worry about moving my decimal or anything, so I can just leave it. All right, so with that in mind, let's solve these couple problems here. So finding the surface area of the following planets. Write your answers in scientific notation. The radius of Jupiter is approximately 44,366 miles. So if we were to put this in scientific notation, we can do that before or after, right? So it does say write your answers in scientific notation, so I'm not going to worry about this until I get the answer, I guess. Okay, so first thing is first, 4 pi times, and then I have 44,366 to the 2nd power. Now, that right there is a very large number. So when you go to put that in your calculator, if you go to do 44,366 to the 2nd power, you're going to get like a huge, gigantic number. So rather than trying to deal with that, instead, I'm going to put this in scientific notation and do it that way. So here's my decimal at the end, right? If you don't see it, you know it's at the end. So 1, 2, 3, 4. So this is going to become 4.4366 times 10. Now, this is really 10 to the 0, so if I made this number smaller by moving it 4 places, I would have to make that bigger. So instead of putting in this really large number here, that may not even show up on our calculator depending on how big it is, if I put my scientific notation in there, we can still do it this way. So then I'm just doing 4.4366 to the 2nd power, right? Which is 19.68 times 10 to the 8th, because 2 times 4. And now I can multiply this out. So let's see. So I'm just going to forget about the pi right now. I'm just going to multiply these two. And I end up with 78.72, I believe. And then, of course, we have that little problem here where we got to move that over and add 1. So it's 7.872 times 10 to the 9th. And then if you wanted to multiply out that pi, then you would end up with 24,718 times 10 to the 9. Move that over 1, add 1, so we would get 2.4718 times 10 to the 10th. All right, so let's try doing this right from the get-go with the scientific notation next time. Okay, so for this one, this is the radius right here. So if this is scientific notation, it would be 3.863, and then I had to move my decimal 3 places, so times 10 to the 3rd. I know my surface area formula is 4 pi, and then it's 3.863 times 10 to the 3rd. So what do we get? 3.863 squared is 14.92 approximately. So I have 4 times pi times 14.92 times 10 to the 6th. So I'm just going to multiply these three together. So 14.92 times 4 times pi, and I'm going to get 187.5. And now I'm just going to move that decimal over 2 spots this time. So I'm going to add 2, and that's going to give me 1.875 times 10 to the 2. And that would be my answer for the surface area there. Oh, 10 to the 8. I think it said 10 to the 2, but I wrote it properly. Okay, let's do this one more. Okay, on February 17th, 1998, Voyager 1 became the most distant man-made object in space at a distance of this here, 10 billion, whatever. How long did it take Voyager 1 to travel this distance, given it traveled this much each day? So essentially, we're trying to find how long it took, which would just be your distance divided by your rate. So we're going to take this distance here, but we're going to put it in scientific notation. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 1.04 times 10 to the 10th. And we're going to see how many of these fit into that. 1, 2, 3, 4, 5, 6. So it's 1.39 times 10 to the 6th. So like I showed you up at the top, we're going to divide the 1.04 by the 1.39, we get 0.748. And then when we divide these exponents, 10 minus 6 gives us 4. Now this is not in proper scientific notation because there's no number in front of the zero other than, or no number in front of the decimal except for basically a 0. So we have to move that decimal over 1, making this number bigger. So this exponent over here is going to get smaller. So it would take them 7.48 times 10 to the 3 days. And since we can move that 3 places, 7,480. Said how long did it take so few days? And that's our answer. So sometimes we need to get it out of scientific notation for the answer to make sense. Sometimes the number is just too big. We need to keep it in scientific notation. All right, so finally, we're just going to practice using all these properties in these more complicated problems where multiple properties are going to be needed to simplify it. Now, there's no particular order in which you need to do them, but I do kind of follow a general pattern when I do them. So parentheses is kind of the first thing I try to eliminate if there are any. My second thing I try to kind of get rid of is negative exponents. And then after that, I kind of just multiply or divide any like terms and whatnot. So the first problem, there's no parentheses, there's no negative exponents. So I'm really just going to multiply or divide any like terms that I have and then use the properties accordingly. So 15 divided by 5, of course, is simply just 3. But then over here, I have the two z's that I'm going to divide. And when I divide those, I'm going to subtract the exponents. But because I have a bigger one on the bottom, I know that my z squared is going to go on the bottom. Okay, same sort of concept here for number 2. So there's no parentheses to get rid of, no negative exponents. So I'm just going to multiply or divide. So this one's division. So 24 divided by 16, that doesn't divide evenly, so then you just reduce it. So these are both reduced by dividing by 4. Actually, no, dividing by an 8. So, oops. So we can make this a 3 and a 2. Now, for the a's, we have a to the 3rd and a to the 4th. So if I do 4 minus 3, I'm left with just the 1, and that will be on the bottom. And then when I do my c's, 6 minus 3 is 3, and that one will be on the top because there were more c's on the top. Okay, number 3. Again, just because there's no multiplication sign on these problems, it's really the same thing. Again, no parentheses, no negative exponents. I'm just going to go about multiplying and dividing. Now, just like you can in normal fractions, if there's ever anything on the bottom and the top that are exactly the same, they can be canceled. So I can cancel those 2's. So now on the top, I have a to the 5th, because when I multiply those 2, I add the exponents. And on the bottom, I have b to the 3rd. Okay, number 4. There's parentheses here, so I'm going to get rid of those first. So now on the top, I have r squared, 2 to the 3rd, s to the 3rd. On the bottom, I have s cubed, and then this r is going to be r to the 6th. Okay, so now 2 to the 3rd, I can work that out, right? And that's just going to be 8. Then I have the r squared on the top and the r to the 6th on the bottom. So 6 minus 2 is 4, and that answer would have to go on the bottom because the 6 was bigger than the 2. And then these are both s to the 3rd, so those are going to cancel, and that's leaving me with just 8 over r to the 4th. Okay, number 5, no parentheses, no negative exponents. I'm just going to look for the things I can combine. So I have an x to the 3rd over an x. So that will be an x squared on the top. Then I have my y and my y squared. So that's going to just give me a y on the bottom. And then the z squared and the z to the 3rd will give me a z on the bottom. Okay, number 6, again, no parentheses, no negative exponents. Now there is a negative number here, but that's different than a negative exponent. You just divide that like normal. So 40 divided by negative 8 will be negative 5. Then I have the p's. 3 minus 1 would be p squared. And then the q's, 4 minus 2 would be q squared, but that one goes on the bottom. Notice my negative is still on my answer there because it was not an exponent. Okay, number 7, I'm going to distribute or get rid of that 2 first. Now, when you have a negative here, this is really like a negative 1. So I would advise you to just make it a negative 1 and put it in parentheses. So this then becomes 3 squared r to the 6 on the top, negative 1 squared s to the 4th on the bottom. Now, lucky for us, negative 1 squared is just going to be a 1, so it's not going to matter, right? 3 squared is 9. And so then that's our final answer. But sometimes it doesn't end up canceling out, and you do have a negative left in your answer, so you have to be careful. Okay, number 8, I'm going to get rid of all my parentheses first. Again, I'm going to treat this negative x as a negative 1x, and that 3 is going to go to the negative 1, the x, and the y. So I have 5 squared, x to the 4th, y to the 8th on the top. On the bottom, negative 1 cubed, x cubed, and y to the 15th. Now here's an example of where that negative is not going to go away because negative 1 to the 3rd power is still negative 1. 5 squared is 25. Now x to the 4th over x to the 3rd will leave me with just the 1x on the top. Y to the 8th on the top, y to the 15th on the bottom leaves me with a y to the 7th on the bottom. And then I can just simplify this. The negative doesn't really matter where you put it, if it's on the top or the bottom or in the middle like this, as long as you still have it accounted for. Okay, number 9, no parentheses on the top, but we do have them on the bottom, so this little 2 has to go to all of those. So I have 4 x squared and y squared on the top. On the bottom, I have 4 squared, x to the 4th, and y squared. Now the y squares are going to cancel. So on the top, I have 4. On the bottom, I have 16x to the 4th. And of course, those can be reduced. So you're going to end up with 1/4 and then an x squared on the bottom. Okay, number 10, get rid of those parentheses first. So I have a to the 3rd, b to the 9th, z to the sixth, a to the second, b to the fourth, z to the sixth. The z's cancel. The a's, I subtract my exponents, I'm left with 1a on the top. With the b's, I subtract my exponents, I'm left with 5 on the top. And then I can just write a, b to the fifth for my answer. Okay, number 11. There's no parentheses here, however, there is negative exponents, so I'm going to rewrite this getting rid of those negative exponents. So I have 3a squared on the top, and an a and an x on the bottom. This x will now go to the bottom, and my 2 becomes positive, and my y goes to the top, that 1 becoming positive, so I don't really need to write it. So now to simplify this, I am going to have 3a on the top because this 2 minus 1, right? Then on the bottom, I have x cubed, and then I still have my y left on the top as well. All right, so now I'm going to do this one. Now this is a negative and parentheses. So first I get rid of the parentheses, then I'll get rid of the negatives. Sometimes it solves itself. So I have 1 to the negative 2 on the top, a to the negative 2 on the bottom, and then this becomes b to the positive 2 because when you multiply the two negatives. So now just these two need to swap. So on the top, I now have a squared. Notice it's positive now. On the bottom, I have 1 squared and b squared. Now 1 squared, of course, is just 1. So my final answer is a squared over b squared. Okay, number 13, getting rid of this negative 1. 4p squared times 2 to the negative 1 times p to the negative 2 times q to the negative 1. Now, to get rid of my negative, since it wasn't already a fraction, I kind of write it as a fraction. So I know my 4 is going to stay on the top, and my p squared, is going to stay on the top. My 2 is going to go to the bottom, and my p and my q go to the bottom, and all those exponents become positive. Now I can just reduce this, making that a 2. The p's cancel, and so I'm left with 2 over q. Okay, these, getting rid of those parentheses, so I have 2 to the negative 2 over x to the negative 2, and then over here on the top, I have x to the negative 3 and 2 to the negative 3. Now, all of these are going to get switched because every single one of them has a negative. And now I know I'm going to simplify these, which is really just 8 over 4, which is 2. And then on the bottom, I'm just going to have that x. Okay, 15, getting rid of this exponent here and here. So p to the negative 1 and q to the positive 2. On the bottom, p to the negative 4 and q to the negative 2. I'm switching everything but this q. This q here is going to stay because it's already positive, right? So that q stays on the top. And then this p from the bottom and the q from the bottom come up. And the p from the top goes down. Now, 4 minus 1 is p to the third, and 2 plus 2 is q to the fourth. All right, home stretch here. So now this one, I'm going to get rid of my parentheses first. You don't have to do it that way. That's just the way I like to do it. And then this will be negative 2. On the bottom, I already have my b squared, and now I have a b to the first. So I end up with, now you can either combine these first and then flip, whatever you need to do. On the bottom, I have b to the third. On the top, a to the negative 3, which then, of course, has to move down. Or if you moved them down and then combined, you should get the same thing. Okay, number 17. 2 to the negative 2, u to the negative 4, u to the negative 2, v to the negative 2. So all of these are going to flip to become positive. And now I have these two can subtract, right? So if I have 2 u's on the top, 2 and 4 on the bottom, I'm going to have 2 left on the bottom, and the 4 and the v squared stay. And then my last one here, this negative 3 goes to everything. So 3 to the negative 3, p to the positive 3, 2 to the negative 3, and q to the negative 6. So again, 3 of the 4 are going to flip. The p to the third stays where it is, but the 3 to the third goes to the bottom, the 2 to the third goes to the top, and the q to the 6 goes to the top. So I now have 8 over 27 with p to the third and q to the 6th on the top. All right, and that's it for the 2.1 notes.